Welcome to this explainer. Look, if you're a senior QA engineer trying to level up your testing infrastructure, you're in exactly the right place. Okay, let's just dive right into this. Today, we're going to build a modern, AI-powered testing workbench, and we're doing it entirely from scratch. We aren't just talking about writing a few basic test scripts here, we're talking about establishing a highly structured, truly intelligent workspace where AI assistants are deeply, seamlessly integrated into your Playwright automation environment.
So, here's our game plan for today. First, we'll cover the SauceDemo foundation. Then, cloning and setup. Third, equipping our AI assistants. Fourth, first AI interactions. Fifth, standardizing project memory. And finally, number 6, the completed workbench. Let's get to it.
All right, starting with Section 1, the SauceDemo foundation, establishing our automation canvas. To begin, our foundation includes all your standard Playwright components. We've got our source folder, and that branches right out into a tests directory, containing spec files like login.spec.ts and checkout.spec.ts. Right below that, we have our pages directory for all the page objects, alongside your utilities, test data, and, of course, the playwright.config.ts file, which handles all those crucial browser and base URL configurations. Really, this setup creates a highly realistic, professional canvas for our AI tools to interact with throughout this explainer. Now, you might be wondering what we're testing. We use a public e-commerce demo site called SauceDemo for this entire setup. Why? Well, because it provides a complete application surface area that maps directly to real-world QA scenarios. You get to follow the complete purchase journey, from login to inventory to the shopping cart and finally checkout. But the best part is, it's not just a happy path. SauceDemo actually lets us practice comprehensive automation on critical bottlenecks. Think valid credentials, locked-out users, sort order validation, and even simulating a slow network. It really is the perfect proving ground. Moving right along to Section 2, cloning and setup, wiring the local environment. For experienced QA engineers, these 4 standard commands are practically muscle memory, right? Clone the repo, run npm install for your dependencies, run npx playwright install for your browsers, and then finish it all off with a quick test command. We absolutely need this traditional baseline functioning flawlessly before we even think about introducing the AI into the mix. And once you run that final npx playwright test command, you'll get that satisfying confirmation that your tests are successfully running against a live browser. At this point, our traditional foundation is rock solid, and we are totally ready for the next phase. Which brings us to Section 3, equipping AI assistants, installing Copilot and Claude Code. First up on the roster is GitHub Copilot. You just install the extension directly within VS Code and sign in with your GitHub account. And hey, a free plan is completely sufficient for this, which is great. Once it's activated, the Copilot icon pops up in your bottom status bar. This immediately gives us our tactical inline coding assistant right exactly where we write our tests. Next, we need to equip our strategic assistant. We do this by globally installing Claude Code right via the terminal. You just use the command npm install -g at anthropic-ai/Claude Code, which taps into the official Anthropic npm package. Actually, a quick pro tip for you here: always visit docs.claude.com to verify the latest install command, because it does frequently change between versions. Once it's installed, you simply open your project folder in the terminal, run Claude, and kick off a session. Let's see them in action in Section 4. First, AI interactions, the agentic loop versus inline generation. Okay, let's look at Claude Code first. With Claude running in your project terminal, you type a prompt like, read this project and summarize what it tests and what is missing. Boom, you just triggered Claude's agentic loop. Now, you can literally sit back and watch as it independently walks through your files at lightning speed. It reads playwright.config.ts, dives deep into the pages directory, and scans the tests directory. Then, it turns around and generates a comprehensive map of your existing test coverage and explicitly points out your gaps. This right here is your first real taste of true agentic workspace analysis. It's awesome. The absolute crucial point here is understanding the strictly different roles these two tools play. Claude acts as a strategic agent. It's meant for workspace-wide reading, deep file analysis, and high-level architectural understanding. Copilot, on the other hand, acts as your tactical partner. It lives exclusively inside your editor for rapid, line-by-line code generation and intelligent autocomplete.
So let's see Copilot's tactical power in action inside loginpage.ts. Place your cursor after the last method and simply write a plain English comment, something like method to verify error message when using wrong password. You press enter, Copilot suggests the entire Playwright method, and you press tab to accept it. It instantly fills out the locators, the username inputs, the button clicks, and the assertion. But, and this is a big but, here is the senior QA check. You must always review what it generated. Ask yourself, does this perfectly follow the comments, or did the AI take a shortcut with brittle locators? Remember, it's a partnership, not an autopilot.
All right, Section 5, Standardizing Project Memory, Scaling for Senior QA Teams. Individual productivity is fantastic for sure, but as senior QA engineers, we need consistency at scale. We achieve that scale with Claude by creating a simple Claude.md file right in the root directory. This acts as memory injection. You write your specific testing standards in this file. From that point on, whenever you start a brand new session and ask Claude a question, it will automatically read and remember your project's standards without you ever having to manually re-explain them. It basically becomes a permanent knowledge base for your AI agent. And we apply a very similar principle to Copilot for seamless team synchronization. By adding a .github/copilot-instructions.md file to the repository, you guarantee that every single developer cloning this repo, whether that's developer A, B, or C, receives the exact same standardized code suggestions. Whether they are writing logging functions or naming variables, Copilot automatically follows your customized team-specific coding conventions. It's a real game changer for team alignment.
Finally, Section 6, the completed workbench, ready for advanced automation.
Your completed workbench now features a working Playwright target hitting the SauceDemo application. But more importantly, Claude Code and GitHub Copilot are fully configured, seamlessly integrated, and hardwired with your specific project and team standards via those Markdown files we just talked about. You are no longer just writing scripts, my friends. You are operating a modernized QA command center. Which leads us to our final thought for this explainer. Your codebase is established, and your strict team standards are permanently injected into the AI's memory. The AI workbench is ready and waiting. So, the only question left is, how quickly will you deploy it to conquer your team's most complex automation bottlenecks? Thanks so much for joining me on this explainer, and I really look forward to seeing what you build.